Welcome back sa aking channel at FB page na GTR Math Tutorial. So for today's video, I will discuss integration of rational fractions, case number 3. So when denominator contains irreducible quadratic factors and none is repeated, to each non-repeated irreducible quadratic factor ax squared plus bx plus c, there corresponds the partial fraction of the form a times 2ax plus b plus uppercase B over ax squared plus bx plus c, where 2ax plus b is the derivative of the denominator ax squared plus bx plus c. Okay, so we have two examples, number 5 and 6. So I hope you already watched the first two cases, case 1 and case 2. Try to solve first before watching my solution for number 5 and number 6. Okay, so let's answer number 5. Okay, so we have integral of x plus 2 over x squared plus 6x plus 13. Okay, first step is try first if the denominator is not factorable. So our constant is 13. So the only factors, 13 is a prime number. So the factors of 13 is only 13 and 1. From 13 and 1, we cannot make a sum of positive 6. So therefore, this is not reducible. So or not factorable. So therefore, we will use case number 3. Okay, so we have x plus 2 over x squared plus 6x plus 13. So that is equal to a times the derivative of x squared plus 6x plus 13. That is 2x plus derivative of 6x is 6. Derivative of 13 is 0. Okay, plus b over x squared plus 6x plus 13. Okay, so we have same denominator. So we can simply cancel this by multiplying both sides of the equation by x squared plus 6x plus 13. So therefore, we have x plus 2 equals a times 2x plus 6 plus b. So now equate the coefficients. So equating the coefficients, so we have x and the constant. So coefficient of x, so we have 2a, and then we don't have x in this part for b, and then that is equal to coefficient of x is 1. So therefore 2a equals 1. Solving for a, divide both sides by 2. Therefore the value of a is equal to 1/2. And then for b, equate the coefficient of b. So we have 6 times a, so we have 6a, and then we have b equals the constant. The constant is 2. Okay, so substitute the value of a. The value of a is 1/2. So therefore, we have 6 times a is 1/2 plus b equals 2. 6 times 1/2, that is 3 plus b equals 2. And then subtract both sides. Subtract 3 to both sides. So therefore, b is equal to 2 minus 3. We have negative 1. So therefore, the integral is now equal to integral of x plus 2 over x squared plus 6x plus 13 is equal to the value of a is 1/2. So just substitute 1/2 here. So we have 1/2 integral of 2x plus 6 over the denominator. We have x squared plus 6x plus 13 dx. And then the value of b is negative. So we have negative dx over x squared plus 6x plus 13. So for the first part, this is in the form integral of du over u, because 2x plus 6 is the derivative of x squared plus 6x plus 13. So it is in the form du over u. So therefore, the answer to this is 1/2 ln of the denominator x squared plus 6x plus 13. Then for this part, we will use the formula integral of du over u squared plus a squared. The formula for that is 1 over a arctangent u over a plus c. So for case 3, this will always be the integrals that we're going to use, the formula, integral of du over u, and then the next part is the 1 over a arctangent u over a. So first, we need to complete the square of this. So let's isolate the solution for this one. So we have negative, or just put the negative here. So we have integral of dx over x squared plus 6x plus 13. So first is we complete the square. So let's complete the square. X squared plus 6x. What must be the last term to make it a perfect square trinomial? So x squared plus 6x. What should be the last term to make it a perfect square trinomial? So the formula is 1/2 of the coefficient of x. So 6 divided by 2 and then square it. 6 divided by 2 is 3. 3 squared, that is equal to 9. So therefore, we break 13 into 9 plus 4. Okay, so we have x squared plus 6x plus 9 and then plus 4. And then we will regroup that and then express this as square of binomial. So therefore, we have dx, integral of dx over x squared plus 6x plus 9, that is equal to x plus square root of 9. So x plus 3 squared, and then 4 can be written as 2 squared. So now it is in the form du, integral of du over u squared plus a squared. Our u here is x plus 3 and our a is 2. The du, differential of x plus 3 is equal to dx. So therefore, it is in the form integral of du over u squared plus a squared. So just apply directly the formula. So we have, so apply the formula, we have 1 over a. Our a is 2. So we have 1 over 2. And then we have arctangent u over a. So the value of u is x plus 3 over a 2. So arctangent x plus 3 over 2 plus the constant of integration c. So this is now the final answer. Okay, so next example, number 6. Number 6, so we have 6x squared plus 3x minus 2 all over x plus 1 times x squared plus x plus 1 dx. So it is combination of case 1 and case 3. For the first factor, x plus 1, so this is case 1 because it is linear in the form ax plus b and there is no exponent. Okay, and then for this is case 2 because this is irreducible. Factors of positive 1 is only 1 and 1. And then from 1 and 1, we cannot make a sum of positive 1. So this part is case 3 irreducible. So therefore, we isolate this. We have 6x squared plus 3x minus 2 all over x plus 1 times x squared plus x plus 1. So that is equal to, for the first part, we have a over x plus 1. And then for the second part, we have b times derivative of x squared plus x plus 1. That is equal to, derivative of x squared is 2x, derivative of x is 1. Derivative of 1 is 0. So we have plus c all over x squared plus x plus 1. Now, let's remove the denominator by multiplying both sides of the equation by this factor. So we have x plus 1 times x squared plus x plus 1. So we can simply cancel this. So what will remain in the left side is the 6x squared plus 3x minus 2 equal. So distribute this. So we can cancel x plus 1. So we have a times x squared plus x plus 1. Okay, and then we have plus b. And then we have 2x plus 1. And then we can cancel the x squared plus x plus 1 and the denominator. So we have to multiply it by x plus 1. And then plus, again, distribute this to c. So cancel the denominator and this. So we have c times x plus 1. Okay, next, equate the coefficients. But first, let us simplify this. Let's simplify this. So just copy the rest. So we have 6x squared plus 3x minus 2 equals a times x squared plus x plus 1 plus b. So multiply the outer 2x times x, that is 2x squared. Combine the outer and the inner. 2x times 1, so that is equal to 2x. 1 times x, that is positive x. So combine that, 2x plus x, that is equal to positive 3x. and then 1 times 1, we have positive 1 plus c times x plus 1. So we can now equate the coefficients. Okay, so highest coefficients or highest exponent is 2. So equate the coefficients of x squared, x, and x to the 0 or the constant. Okay, equate the coefficients of coefficients of x squared. So we have x squared, no x squared for c, and then this one. So therefore, we have a plus 2b equals the coefficient of x squared. So we have 6. Equation number 1. Then equation number 2, we have coefficients of x. So we have a, and then we have plus 3b, and then we have c. Okay, so we have a plus 3b plus c plus 3b plus c equals the coefficient of x here, that is equal to 3. Equation number 2. And then for the constant, so we have this one, we have a, and then we have another a, or another 1, so times b, so 1 plus b, and then another 1, so plus c again, equals the coefficient, the constant, negative 2. So we can solve the values of a, b, and c by elimination method. So let's use elimination method. We can eliminate, let's eliminate c in equation 2 and 3. So this is equation number 1, equation number 2, and equation number 3. So by subtracting 3 from 2, we can eliminate c. So we have equation 2 minus equation 3. So we have a plus 3b plus c equals 3. And then equation 3, we have a. Let's change the sign. Negative a, negative b, negative c equals negative 2 will become positive 2. So then just add, since we already changed the sign, we can cancel this and also cancel the a. So therefore, we have 3b minus b. We have 2b is equal to 3 plus 2. We have 5. So therefore, the value of b is 5 over 2. Okay? We have value of b 5 over 2. So substitute from equation number 1. So we have a plus the value of b is 5 over 2. So we have 2 times 5 over 2 equals 6. So we can simply cancel 2. And then 5 subtract from 6. So we have a is equal to 6 minus 5. A is equal to 1. And then from equation number 2, we can substitute the value of a and b. So the value of a here is 1 plus 3 times the value of b, that is 5 over 2, plus c equals 3. So simplify. So we have 1 plus this 3 times 5. So we have 15 over 2 plus c equals 3. Subtract 1 to both sides. So, or we can multiply both sides of the equation by 2. Okay, so we have multiply both sides of the equation by 2. So we have 2 plus 15 plus times 2. So we have 2c equals times 2 equals 6. And then combine this. So we have 2 plus 15. So we have 17 plus 2c equals 6. Therefore, 2c is equal to 6 minus 17. 6 minus 17, that is equal to negative 11. And then divide both sides by 2. So therefore, the value of c is negative 11 over 2. Okay? Now that we have the values of a, b, and c, so we substitute that to this equation, to this expression. Okay? So we have, and then put the integral symbol for each a, b, and c. So therefore, the answer will now be equal to, so this part, the value of a is 1. So we have integral of dx over x plus 1. Okay, and then plus b, the value of b is 5 over 2. So we have 5 over 2 integral of 2x plus 1 over the denominator is x squared plus x plus 1. Put the dx in the middle. And then plus c, the value of c is negative 11 over 2. Integral of dx over x squared plus x plus 1. So for the first two integrals, we're going to use integral of du over u that is equal to ln of u plus c. And then for the third part, we will use integral of du over u squared plus a squared. So first we need to complete this x squared plus x plus what should be the number to make it a perfect square trinomial. So we just divide the coefficient of this by 2. So the coefficient of x is 1 since there is no coefficient. So that means there is 1. So divide by 2, 1/2, and then square it. So the last term should be 1 over 4. Okay? So therefore, we will break 1 into 1/4 and then plus 3/4 because 1/4 and 3/4 that is 1. Okay, so for the first two, we will use the du over u. The derivative of x plus 1 is dx or the differential. X plus 1 is dx. So therefore, this is ln of x plus 1. And then for this part, we have 5 over 2. Derivative of x squared plus x plus 1 is 2x plus 1. So again, it is ln of x squared plus x plus 1. And then for this part, so we just transform this into integral of du over u squared plus a squared. Okay, so therefore we have dx over, so we have x squared plus x plus 1/4 and then plus 3/4. Then express this as a square of binomial. So as a square of binomial, so just square root the 1/4, that is 1/2. So that is equal to x plus 1/2 squared. And then plus, we will get the square root of 3/4. 3 is not a perfect square, so therefore that is equal to square root of 3 over square root of 4 is 2. And then we put the square. So it is now in the form integral of du over u squared plus a squared. So our u is x plus 1/2. The differential of x plus 1/2 is dx. And our a is square root of 3 over 2. So the formula is equal to 1 over a arctangent u over a and then plus the constant of integration c. Okay, so let's just copy the first two, ln x plus 1 plus 5 over 2 ln of x squared plus x plus 1 and then minus 11 over 2. So times 1 over a. 1 over a. This is our a, so that is square root of 3 over 2. And then we have arctangent u over a. So we have x plus 1/2 over square root of 3 over 2 plus c. So we just need to simplify. So how to simplify that? We use the complex fraction formula a over b all over c over d. That is equal to the product of the outer. We have AD equals the product of the middle BC. So we just use this. And then for this part, x plus 1/2. So we can put 1 here and then add in adding fraction. So we can use the cross multiplication, the butterfly technique. Okay, so to simplify that. And then the 2 will go up here. So, or we can simply cancel 2, 11 over 2 and then square root of 3 over 2. So we can cancel the 2. Okay, so therefore just simplify this. So this part, so this will become x over 1 plus 1/2. So cross multiply x times 2, so that is equal to 2x. And then 1 times 1, so we have plus 1 over 1 times 2, we have 2. All over square root of 3 over 2. So as you can see, we both have denominator of 2. So just simply cancel 2. What is left is 2x plus 1 over square root of 3. So therefore, the final answer is, so this is the final answer, ln of x plus 1 plus 5 over 2 ln of x squared plus x plus 1 and then minus 11 over square root of 3 arctangent 2x plus 1. So 2x plus 1 over square root of 3 plus the constant of integration c. So this is our final answer. Okay, so that's it. So I hope you learned something from this video and see you on our next case number 4, the repeated. Okay, so thank you for watching and see you on my next video. So if you have math question or integral calculus question, just comment your question here or DM me in my messenger RJ Enseñado or comment in my Facebook. Okay, so again, thank you for watching. Bye-bye and God bless.